We're looking at a simple motion problem taken from page 54 of your textbook, number 57. We have Nora jogging to a bank building that she knows is some distance, and that distance is 4.3 kilometers from her home. Maybe she remembers seeing it on Google Maps whenever, or on her watch whenever she used to jog it, seeing get to the bank and you're at 4.3 kilometers. She also knows, based upon her smartwatch maybe, that she forgot this time around, that she always runs at a pace at about 4.0 meters every second. The question is, if she's traveled 4.3 kilometers, and she knows that her average pace is 4.0 meters every second, how long has she been jogging up to this point? We can imagine this as a bit of a picture. Here's Nora, right? And she's been jogging along some distance, right? This distance is 4.3 kilometers, and that's the bank building that she gets to. She knows that her speed in doing that is 4.0 meters per second. What she wants to know is her time, how long she's been traveling. There's a few ways we can look at this. First, we're going to describe a bit more explicitly what we mean by 4.0 meters per second. We could write that as 4.0 meters for every second. For every 1 second, 4.0 meters. This would be equivalent if we wrote 1 second, 4.0 meters. Saying the same thing just a little differently, right? For every 1 second, she travels 4.0 meters. Every 4 meters, 1 second has passed. This way of representing her speed, a little differently here, is going to be helpful for us, because if we represent it this way as 1 second for every 4.0 meters, then we can say, well, I know she traveled a total distance of 4.3 kilometers. Notice I have a distance over a distance, so these two units will be able to cancel, and I'll end up with only seconds, or time, which is what I want. Now there's a problem here, however. Though I can cancel the units, I can only do so if they're the same unit. Right now I have kilometers and I have meters. So I need to convert these kilometers into meters. These kilometers here into meters. Or I can convert these meters here into kilometers, but I'm going to convert these kilometers into meters. What do we do there? We need another conversion factor. So we need to add one to the right here, a conversion factor for kilometers into meters. Well, I'm in kilometers, so that means I need to get rid of kilometers, so it's going to go down here. I need meters up here. For every 1 kilometer, how many meters are there? Well, by kilo, we mean 1,000. So 1 kilometer has 1,000 meters in it. Notice here, kilometers in the top, kilometers in the bottom. So kilometers can go away. Great. Notice also meters in the bottom, meters in the top. So meters go away. So now all I have left is what unit of measurement? Seconds. So now I have 1 second times 4.3 times 1,000 divided by 4. And that gives me my total time in seconds. So 4.3 times 1,000 and then divided by 4 gives me a total time of 1,075 seconds. Now, what can I actually report as the amount of time based upon significant figures? Well, the amount of significant figures I have, I look back at my distance and I measured this time according to the 4.0 and the 4.3. Each of these have 2 significant figures, so I can only have 2 places here in my number. That means I actually have 1,100 seconds. I can't be this precise here. This is more precise than this guy. So 1,100 seconds is what I would say is the amount of time that she'd been jogging. We can convert that into minutes pretty simply. If we start again with 1,100 seconds, and we need to get into minutes, we need some conversion factor here to convert from seconds into minutes. I'm starting in seconds. I need to get rid of seconds, so they have to go in the bottom. I want to get into minutes, so those go up top, so they'll stay in my equation. Well, for every 1 minute, how many seconds are there? 60 seconds. Notice the seconds will cancel. All I'm left with are the minutes that I want. So if I take 1100 and divide it by 60, I end up with a time of 18.3 repeating, mathematically speaking, 18.3 repeating minutes. Again, I only have two significant figures here, so I can only report this as 18 minutes. 18 minutes that she's been jogging, and here's my answer. Now, I could have done this a little bit differently. Instead of doing this sort of swap here of meters per second, changing it to seconds per meter, so that I could do this sort of math here, right, and cancel the units. I could also recognize how we define velocity or speed. Speed is distance over time, right? I have her speed here. What's her speed? Her speed is 4 meters per second, right? Speed is 4 meters per second, so I have speed. I know her distance as well. That's my 4.3. What I don't know is the time. I don't know time. So I can transform this equation and solve for time. Okay, if I solve this equation for time, what will I have? Well, I'm going to rewrite this as S equals d over t again. Solving this equation for time, I need t by himself, right? All right, well, right now, t is below distance. I need to get him on the top side of our equation. To do that, multiply both sides by t. See, now the t leaves the bottom here. It's not at all on the right side anymore, but now it's on the top. Remember, I did this because if I multiply t by this right side to get him out of the bottom, I also have to do the same to the left side because of this equal sign. In order for the equation to stay equivalent, I have to do whatever I do to one side, I do to the other side. So now I have t times s equals just d. Don't quite have t by himself yet. Remember, t is what I'm looking for. To get t by himself, I just need to get rid of his friend, s, which is my speed. He's being multiplied by t, so I got to do the opposite to get rid of him. Divide by s. If I do that to one side, I have to do that to the other side. So now what I have left is, s is now gone, and all I have left is t. T equals, or time, distance over speed. Here's an equation that I can use and relate it back to the problem. The distance is 4,300 meters. The speed was 4.0 meters per second. So that should give me the time. And we find again that this is actually the same math that we did, which was 4,300 meters divided by 4. Ends up being the same math. This is just two different ways of actually accomplishing the same mathematical process, right? So here we recognize, well, I can flip this guy around and do this sort of math. Actually, that was very similar to what happened here, right? But here we just started with the general formula or equation for how we define speed. And we end up down here with the exact same answer because it's the same math that we performed up here. All right, thank you.